morning everyone.
Morning.
And good morning to Mrs. Edgar. So this time, our group we are going to present about stokastik process and our research about analyzing the number of students in laboratory, LPD laboratory at 11:30 a.m. until 1 p.m. using first business time and occupancy times. Before we going into our presentation, let us introduce ourselves first. I am Francis Ryan, and this is.
I'm Ida Desong Putri, anggota itu baru ini.
I'm Firadiana Najwa.
I'm Isani Sobat.
I'm Berhadi Bertapia Putri.
I'm Winda Diana.
I'm Bukado Ayu. I'm Siti Fadila.
I'm Ajit Puspitadenu.
I'm Nurdia Jayani. I'm Syarjalayan.
For beginner presentation, we are prepare our outline first. The first one, we are going to explain about introduction, literature of the study, method of research, discussion, and the last one is conclusion. The first one is introduction, will be explained by Kira.
Okay, good morning everyone. At first, I will give you some explanation about stokastik process. The rate inflation in United States in the end of the end week. And the second is the number of customers that entered the store book in JN. And the last is the number of six-sided die. What I have already mentioned before, this is what we call stokastik process. And I'm quite sure that if we do not have already studied about stokastik process, if we never solve a problem of a stokastik process, we will not understand about stokastik process itself.
Yeah.
So, in this big assignment, we have to find one about the stokastik process in real life. And after doing some discussion with my team, we have already choose the stokastik process number of mathematics department students in LPD laboratory. Big why is why we choose LPD laboratory. Since we have another laboratory, we have a modeling laboratory right beside the LPD. We have computation laboratory over there, up there in the 4th floor. Then the big reason and the most important reason why we choose LPD laboratory because this laboratory is the most visited laboratory. The reason is why, because all of the students, most of the students in mathematics department use a major focusing in research operation and pemodelan for their study. So it's lucky that we have the most visited laboratory is the LPD laboratory. And another reason why we choose LPD laboratory is, as you know that the place of LPD laboratory is closer than any laboratory itself. So, what we do in our case is collecting the data about the visitors in LPD laboratory. We collect the data from 11:30 until 1 p.m. And we collect the data about 7 days from 12th of October until 20th of October. And by collecting the data, by doing this observation, we get 31 data in a day. So, yeah, you can calculate 31 times 7, and that's all the data for our stokastik process. And the most important in this observation is our data, because all of the data that we have already collected before is really, all of the theories that we will apply in the next slide is depend on our data. And after doing this observation, what we have to do is doing some literature review and find some other information about the number of mathematics department students by using some theories that we have already learned in the stokastik process, such as occupancy times and first passage time. And all of the stokastik process and all the theory will be explained by my friend.
After we know the background of the study, let's now about the problem statement. Now, in this topic, we have a 4 point. The first is what is the DTMC model of the number of the visitor in the ROPD laboratory, and the visitors is mathematics students. Then the second is how to construct the transition probability matrix, and the third is how about the first passage time when the ROPD laboratory reach its maximum capacity. And the fourth is how many times ROPD laboratory reach its maximum capacity. Then, limitation of the study. Yeah, the first is place of data collecting. The place of collect the data is ROPD laboratory in this place. And the second is type of data collecting. We collect the data from 12 until 20 December. 2070. It's seven days during 11:30 a.m. until 1 p.m. every 3 minutes. And then the third is maximum state. The maximum state is xn, and the maximum state is begin from 1 until 70. So the maximum state is 70. And the 4 is main focus of the research. We focus on the number of visitors. Then the purpose of the study. The first is to find out the DTMC model, and the second is to construct transition matrix. Then the topics is his contribution of the study. The first is being an information for knowing further about DTMC theory. It's the application for DTMC theory in the real life. And then the second is being a solution to predict the number of visitors in ROPD laboratory. The visitors is the mathematics department students. And the third is being an information about ROPD laboratory according the first passage time and the occupancy time.
And the second is literature of the study. In the first is random process. Population type of population type from random process can be defined as if X is a random process, then the population from random process is all possible values that can be involved in any process. For example, is S equal Y xt equal Y for T element T. If X is a random process like the equation, the population of X is can be defined as a value that status equation. There are two kinds of a random process. That is, in the first is if the population of random process is countable, it is called discrete time. For example, is S equal 1, 2, 3, and etc. And the second is if the population of random process it is uncountable, it is called continuous time. The example is S equal infinity. In the second is Markov chain definition. A stochastic process xn bigger than 0 on state space S is said as a DTMC if for any ing in S is the equation is the conditional probability like that equal the conditional probability like that. And DTMC xn bigger than 0 is said that homogeneous for all and equal 1, 2, and etc. is the conditional probability like that equal the conditional probability like that. In the first equation, it is that the conditional probability in the left is the same of the conditional probability like that. Sometimes this property is described in words as follows, given the present state of the system, namely Xn. The future state of the DTMC is Xn plus 1, independent of its space, namely x1, x0, x2, xn, and etc. The quantity conditional probability matrix in here is called one step transition probability of DTMC at time n. And in the two equation, you place that for time homogeneous DTMC. The one step transition probability on ing, but is the same at all time. The result notation for the one-step transition probability is given by Pig equal conditional probability xt plus 1 equal g and xt equal I, and it is convenient to arrange them in matrix is like that. Then these are some property of transition probability matrix is like that.
Then I will talk about the concept of the Markov chains. There is 7 types of Markov chains. You can see in the slide, there is a reducible state, irreducible DTMC, accessible, modified state, absorption state, transition, and recurrent. But the difference of this is the transition of the state I and state J. Reachable states, stable states. In this condition, state J reachable to state I if there is a transition from state I to state J. And it's a finite transition. So there is n when 0 less than equal to n equal to infinite. And the irreducible DTMC, when we have a state, when xn, when n is more than equal to 0, so there is a state in S when S is 1, 2, 3 until n. So there is a I and J in S with K more than equal to 0 when probability of xk equal to j given by x0 equal to I more than 0. In accessible, it is given by n more than equal to 0 when Pij power 0 more than 0 and Pia power to 0 equal to 1. In communicate state, there is a difference in this because in this I reachable to j and I reachable to I, so we can write it with I equal if and only if with j. In absorption states, in this state, j absorption to I when the Pia more than 0 and when the I not equal to j and Pij equal to 1. In transition states, in this condition, the probability of F1 is less than with 0 because if there is if the A transition or move to another state, the I is cannot to back with itself. But in the recurrent state, the I is can back to itself. So probability of F1 II equal to 1. And next, I want to explain occupancy time. Occupancy time is the expected amount of time the DTNC spent in a given state during a given interval of time. Now, in this slide, this is a theorem for occupancy time. You can see in this slide where P now is I. P0 is I is the identity matrix, and addition the occupancy time can be applied in expecting number of rainy days in weather model or expecting number of its brand sold in the first and weeks in bandwidth switching model. And then next I want to explain first species message. First species type. First species type is the random time at which a stochastic process first passes into a given subset of the state space. And then this is the theorem of expected first species time given that first species times. This is, and it satisfies the equality you can see in the slide. And also you can read in the book full Karni. This is in that their explanation about first species times.
The next is method of research. This is our method to analyze the data. First step, next step is literature of study. In this step, we collect some literature about discrete time method change, first species time, and occupancy time. Next step is data collection. We collect the data, how the number of passenger in lab ROPD from 12 October until 20 October. The observer collect data every 2 minutes from about 11 until 1 m. Next is consider the transition probability matrix. And next, solve the problem by DMC process time and occupancy time. And next, get the conclusion and finish.
Chapter 4 about discussion. This method explains how to construct the transition probability matrix for number of students in ROPD for every 3 minutes for 7 days on each day. The collected data was written in Microsoft Excel. This is the table. There are 31 data in 1 day. For example, at time 11:30 there are 3 students in lab, and next 3 minutes there are still 3 students. At time 11:36 there are 5 students in lab, and so on for 7 days. After collecting the data, the next step is analyzing the observation result to make sum of event table. This is the table. It starts from 2 until 17. Why? Because at time the observation, the number of never exists. The number of students in lab is 0 or 1 or 18 until 20 students in lab. So it starts from 2 until 17. For example, the occasion of 3 to seven times. Let's read back the table before. At time 11:30, there are on day 1 there are 3 students left, and next 3 minutes still there are 3 students. It's written is 1 time, and at time 11:39 on day 2 there are 3 students, and next 3 minutes there are still 3 students. So it's the occasion of 3 to 3 even happen 2 times, and so on until we get 7 times on of 3 to 3 even. And so get to the other number of this table.
Well, everybody, I will explain about constructing the transition probability matrix. Okay, actually, we have 31 the data because we start from 11:30 until 1 p.m. It is about 90 minutes, and each period we need 3 minutes. So if we divide of 90 minutes over 3 minutes, we have 30. But we start collecting the data at 11:30. So we have 31 data. And let xn be the number of the mathematics student in laboratory room. Then by using TTMC theory, according to the previous explained, we have xn 2 until 17. 2 is defined if the number of mathematics student in laboratory room is 2, and 3 if the number of mathematics student in laboratory room is 3, and so on until 17 if the number of mathematics student in laboratory room is 17. Then we will construct the transition probability matrix. Here we have 0.5 and 0.5. We get it from like this. So if we sum each row, it is 1 plus 1, 2, and we sum 7 plus 2 plus 1 is 10. So if we count the probability matrix of P 2, 2, it means that 1 divides 2. 2 is sum of the each row, and etc. And if we sum of each row in P, it is 0.5 plus 0.5 is 1. It is always 1 for each row, sum of each row, because the maximum value of probability is 1. And it is the way from we have the same way from another.
Okay, I will explain about further analysis with first patched time. We already knew that first patched time is how long the current state lasts, or it means also how long the current state needs time to pass into step n. So, if we talk about our case, the question is what is the expected first patched time of our OPD laboratory to reach its maximum capacity? So to analyze, we have the formula, the expected first patched time. The formula is MR equal 1 plus sum of PIG times by MG from G equal 1 to N minus 1 for I between 2 until n minus 1. Because we have 17 states, so n minus 1 means 16. So,
if we write it down,
and I 1 plus sum of g equal 1 to n minus 1 ig mg for blah blah blah. So we want to find m2 3 until m16. So we put 2 m2 1 m2 1 sum up p2 to 1 m1 and then plus p2 to m2 and so on, and then one, and then you see the P is from transition probability matrix, and then we have 0.5 M1 plus 0.5 M2 M3. Because we don't have step number 1, so it means 0. And so on. If we want to find M3 until M16, the formula is the same. And after that, construct a linear system of equation into matrix form B equal AM. And then we want to make this to B equal AM. So 1 in the right moves to the left, so minus 1. And then M2 in the left moves to the right, so minus 0.5 M2 plus 0.5 M3. And then it's the same for M3 until M16. And then we got the matrix A, C, and then matrix B. And then we define matrix C. C is A inverse. Because we want to find matrix M, so we have M A inverse B. Yeah. By doing the MATLAB, we get the value is M2. And then we see M16 is equal 5.5570. It's not the final result because we declared the step in 3 minutes. So we have to, if we want to convert in seconds, 5.5570 times by 180. So the final result is 1000 and 1001 seconds. So the conclusion is the expected first passage time of our OPD lab to reach its maximum capacity is 1001 seconds.
And then I want to explain how about analysis that occupancy times. Let's assume that occupancy times happen in this case in one day during 11:30 AM until 1 PM. Let's say time 12. After that will be observed all the event happen during tau. So take n equal to 31 because they are why 31 because there are 31 events happen during time tau. Therefore, substitution n equal to 31 to occupancy time formula. This is formula occupancy time. And then because we have 31 during tau, so we can get M30 sigma S equal to 0 until 30 PR. PR, P power 0 plus P power 1 and P power 0 is identity. And then this is matrix of M30. This is step 2, starting from step 2, expected number of visits is 2 and maximum expected number of visitor is 30.
Okay, I will add some explanation about how to compute the value of this for specific style using MATLAB. In this section, we define matrix P minus 1 and so on, and we have to find inverse of A first. So we have this man. So we have this matrix. Like I just said before, and then we have to find A inverse of A, and then times all the equation from the left. So we have A inverse P equal to A inverse AF, and this is we know as identity matrix. So after we compute A, we say we will C, so we have this value. And then for the occupancy times, I think it is a little difficult if we count manually, so we need a MATLAB for help us. We compute this equation, and then we have this matrix. And then the last section is conclusion. We will explain by diagram.
I will tell you conclusion about this presentation. Discrete Markov chain is a useful theory in Stokastik Proses. Discrete Markov chain is a random process where all information in a current condition is only depends on the first previous condition. The implementation of it in this assignment is to predict the number of mathematics department students in ROPD laboratory at 11 a.m. until 1 p.m. The calculation from observation data results obtain the transition probability matrix about the number of mathematics student department in ROPD laboratory. Some other theory that also used in this assignment are occupancy times and first passage times. In this assignment, the accuracy of data retrieval is not accurate enough. It is caused by the data collecting was did every 3 minutes. Meanwhile, there are no guarantee that the number of visitors will steady during that period. And the discussion about this assignment is specific in one case only. It is necessary to develop this assignment into greater and complex condition. After it can be concluded whether the DTMC is applicable for any cases or not. Further study is expected to accomplish this assignment. Thank you for your attention.